Hello YouTube, this is Eric from Coder Snacks. Today, we're going to talk about the data structures and basic concepts you should know before coding interviews. Let's get started. First, no, these are all my opinion. Interviewers have differing opinions about what's important to know. However, when I go in for coding interviews, this is my study list, based on the interview feedback I've seen and questions I've seen asked of hundreds of candidates. I think this is the 20% of the material that will get you 80% of the impact. We're not going to go in depth in this video. I'm going to say a few things that you should know about each data structure. If there's something I say that you're not familiar with, go take a look at it, make some flashcards, however you study. It's a bit listy, but use it as a study guide as part of your practice. For any of these, you should know Big O complexity, common APIs for these structures, how they appear in your language, and when appropriate, how to implement them yourself using simpler data structures. Let's start with the most basic data structure, the array. Most languages also have lists built on top of arrays. Arrays themselves are usually static, whereas you can resize lists or dynamic arrays. You should know that resizing an array makes appending O of n, but amortized O of 1, and you should know how that works and why. You should also know how to make an array and/or list in the languages you're interviewing in. You should know the runtime complexities of finding elements in an array, whether you know the index or not. You should know that arrays are stored continuously in memory and how that affects performance. You should also know how to create and access into 2D and greater arrays. 2D arrays are useful for matrices and some kinds of graph problems. Particularly in Python, you should know why this appears to work but does not. I have seen this mistake many times. You should also know when to use arrays and when to use dictionaries, which leads us into our next topic. There's a half joke, half cliche that you can solve half the interview repertoire with dictionaries and the other half with graphs. Dictionaries are extraordinarily useful, especially if you're trying to reduce the runtime complexity of something. You can often do things in O of 1 with a dictionary that you can only do in O of n or O of log n with other data structures. You should know the runtime complexities of add, remove, and find in the average and worst case. Related to that, you should know how to implement a dictionary using only a hash function and arrays or lists, including how to handle collisions, resizing, and item removal. Let's dig in there a little. You should know what a hash function is and what makes a good hash function versus a bad one, for example, collisions. You should know how collisions are handled in a hash table and why this can lead to hash table performance being O of n in the worst case for lookups. You should also know about sets and how to use them. Let's move on to strings. This is simpler, but you should know how strings work in your languages. You should know about adding or slicing strings and how to modify or build strings. Languages vary widely in terms of what you can do with strings and what you should do to be optimal in handling them. Also, you'd want to be familiar with ASCII and Unicode, how those are represented in memory and how much space they take. Unicode is more and more important as we become more international. Don't get wrecked when your string is in Japanese. An optional topic of study is learning about how string interning works in your language. Next is linked lists. You should know how to implement a single and doubly linked list, and what the runtime complexities are for linked list operations, and thus why people like them so much. You should also know they're widely used for stacks and queues, which brings us to stacks and queues. These are great building blocks to know for several important algorithms. As far as the data structure side of it goes, you should know how to implement them using an array, list, or linked list. You should know about LIFO and FIFO, and which applies to which data structure. You should also know about one particularly important stack, the call stack. Know how the call stack works, how things get put on it and pulled off it, and particularly know that space on the stack is still space, and how much space on the stack recursive algorithms take. Continuing on is trees. You should know what a tree is and why and how it's different from a general graph. You should be able to implement binary trees and n-ary trees. An important type of tree is a tree, T-R-I-E, and you should be able to implement one. Know what a binary search tree is and how to search in it. I differ from a lot of people here, but I think being able to implement a balanced binary tree off the top is not necessary. I haven't seen many people ask such questions. It is important to know what a balanced binary tree is, and that it can be implemented such that inserts and deletes are O of log n. Finally, know the time complexities of various tree operations, and that they're different for balanced and unbalanced trees. While we're talking about trees, let's also talk about heaps. You should know what a heap is, knowing about min heaps and max heaps, and know how to implement them using an array. You should also know that heaps are different than binary search trees, and you should know how and why you would want to use one versus the other. Graphs. Graphs show up in a lot of interview questions. You should be familiar with how to implement a graph and three main methods for representing them: adjacency lists, matrices, and the more object-oriented approach of having a list of pointers to vertex objects in your vertex class. You should know when these are useful when thinking about sparse and dense matrices. You should also know the difference between directed and undirected graphs and when each is appropriate. A lot of the ground to cover for graphs is on the algorithm side, and we'll discuss more there. Make sure you're familiar with bit manipulation. We'll also talk about that more in the next video, but you should know how AND, OR, XOR, and NOT work at a minimum, and some of their uses. You should also have a passing familiarity with 2's complement and negative numbers, and if you want to use Python for bit manipulation questions, you should understand how Python works with bits. Finally, for this 80-20 list, you should know about topics in threading and parallel processing. A common problem extension at companies like Google or Facebook is to ask how you would run some algorithm on very large data when using a farm of computers would be appropriate. You should know that some problems are easily parallelizable and some are not, and what the tools are for dealing with both. In the former case, you should be familiar with ways of splitting problems efficiently so processors can be utilized as much as possible while minimizing the necessary communication. In the latter case, you should be aware of what starvation, deadlock, and livelock are. You should know what locks, mutexes, and semaphores are, and the difference between processes and threads. You should also be aware of threading primitives in your favorite language. Particular to Python, you should be familiar with the multiprocessing module, the threading module, and what the global interpreter lock is. There are many more things we could name here, and many more advanced data structures and concepts that are useful to know, but this should get you quite far on your journey. If there are items you think I should or should not have included, let me know in a comment. Next time, we're going to continue our 3-video interview prep series with a discussion of algorithms you should know for programming interviews. I hope you got something out of this video. If you have any questions, comments, something I've missed, or problems you want answered or covered in the future, let me know in the comment section below. And if you enjoyed this video, it would be great if you liked the video, subscribed, or both. Thanks so much. See you here next time on Coder Snacks.